Okay, so let's talk about balancing redox reactions in acidic conditions. So there's a lot of steps to these problems, and I'm just going to work through an example problem, and we'll take it step by step. Okay, so here is the reaction. So you'll see something like this. It'll have the reaction written out. So here it's iron 2 aqueous plus nitrate, the nitrate ion, which is also aqueous. And then it will either say in the problem, in acidic conditions, or sometimes you'll see it written, acidic conditions, written over the arrow, or sometimes you might just see a hydrogen ion in brackets, meaning this is an acid. So there will be some indication that this reaction is happening in acidic conditions. Either in the problem it will tell you it's happening in acidic conditions, it will be over the arrow, the word acidic, or hydrogen ion concentration. And it's going to produce iron 3 ions and a nitrogen monoxide gas. Okay, so same as before, we need to write out the half reactions and balance them. So I'm going to write out the steps all over here, and then I'll do them together over here. So 1, write out half reactions. So this is a little different because we have more than just 2 elements here. Only 2 elements, one will be oxidized and one will be reduced. One of them, the oxidation number, won't change at all. So let's see, right off the bat here, I can see that iron is going from iron 2 to iron 3. So this is a +2 to a +3. The oxidation number is increasing. That means this is an oxidation half reaction. So let's see what's happening with the nitrogen and the oxygen. So the oxidation number of nitrogen can change. We don't know what it is. We do know the oxidation number of oxygen is not going to change, and it is always -2. So we can figure out what the oxidation number of nitrogen is based on the sum of the charge of the compound or ion. So I know the charge of oxygen is -2. Oxygen is not going to be oxidized or reduced. Its oxidation number never changes. So that means, what is the charge of nitrogen if the overall charge of this polyatomic ion, nitrate, is -1? So remember, we did this before when we were assigning oxidation numbers. So I'm just going to pull this out over here and write it over here. So I know that the charge of oxygen is -2. So essentially something plus 3 times -2 equals -1. Well, 3 times -2 is -6. So what plus -6 is -1? So that means this must be 5. So the oxidation number of nitrogen on the reactant side is 5. So now let's see what the oxidation number of nitrogen is on the product side. So here, this is nitrogen monoxide. This is a covalent compound. It is neutral. So that means if oxygen has a charge of -2, that means that nitrogen must have a charge of +2. So I have +5 and +2. That means the oxidation number of nitrogen is decreasing. It's reducing from 5 to 2. So that means this must be the reduction half reaction. So we wrote out the 2, well, we didn't. So let's write out the 2 half reactions. So I'm going to do oxidation first. So here's the oxidation half reaction. So it's going to be iron 2 plus to iron 3 plus. And then I'm going to write out the reduction half reaction. The reduction half reaction is going to be this nitrate ion, NO3 minus, aqueous, to NO gas. And then we're going to balance the half reactions. Okay, well, to balance the oxidation half reaction, it's pretty straightforward. We are going from +2 to +3. That means we are going to add an electron to the more positive side. Now this oxidation half reaction is balanced. So things are a little more complicated. So the oxidation half reaction is balanced. So now for the reduction half reaction, there's a bunch of rules. These are the rules to balancing this reduction half reaction. First, we need to balance the element being reduced. Balance element being reduced. So we said the oxygen is not being reduced because its oxidation number doesn't change. The nitrogen is being reduced. So we need to balance the number of nitrogens. Well, I have a nitrogen on this side and a nitrogen on this side. So there's one nitrogen on both sides of the arrow. So that is done. So I'm just going to write this down here too, I guess, and we'll go through each step. So balance element being reduced, which it already was, but if it's not, that's the first thing you need to do. So now I'm going to write it again. Nitrate ion to nitrogen monoxide gas. The next thing that you do is you balance the oxygens by adding water. So I'll write that again here. Balance oxygens by adding water. So if you look at this side, there's one oxygen. This side, there's 3 oxygens, which means I must need to add 2 waters to the product side to have there be equal number of oxygens. So I'm going to say, and this is liquid water. So I'm going to say the nitrate ion produces nitrogen monoxide gas plus 2 H2O liquid. So now I've balanced the element, I've balanced the oxygens. Now let's see what's next. I'm going to balance the hydrogens by adding hydrogen ions. I'll write it over here too. Balance hydrogens by adding hydrogen ions. So this side has 0 hydrogen ions. This side has 4 hydrogen ions, so I must need to add 4 hydrogen ions to the reactant side. So 4H plus aqueous plus the nitrate ion produces nitrogen monoxide gas plus 2 water liquid. Okay, now the last thing that you do in balancing this reduction half reaction is balance the charge by adding electrons. I'll write that up here too. Balance charge by adding electrons. So remember, we can only add electrons to the more positive side of the arrow because we're adding something that's negative. So the charge on this side of the reaction is 0. The charge on this side of the reaction is +4 minus 1. It's +3. 4 plus charges, 1 minus charge, +3. That means I must need to add 3 electrons to this positively charged side, the reactant side that has a charge of +3. So electrons are aqueous. So 3 electrons plus 4 hydrogens plus the nitrate ion produces nitrogen monoxide gas plus 2 liquid water. Okay. So now we have balanced the 2 half reactions. Now we are ready to add them together. So this is my balanced reduction half reaction. This is my balanced oxidation half reaction. Remember, the number of electrons when I add these together need to cancel because electrons don't belong anywhere in the final balanced equation. So if this has 3 electrons on the reactant side and this has 1 electron on the product side, I'm going to multiply this whole thing by 3. And when I do that, I get 3 iron plus 2 aqueous produces 3 iron plus 3 aqueous plus 3 electrons. Now my electrons can cancel. I'm just going to write this reduction half reaction up here so we can add them together. So these are the steps. Write half reactions, balance half reactions. Then I'm going to say add half reactions together so that electrons cancel. Okay, so I'm just going to rewrite this equation right here. Okay, so now I'm going to add these 2 half reactions together, knowing that the electrons will cancel. So now I have 4 hydrogen ions, aqueous, plus the nitrate ion, aqueous, plus 3 iron 2 ions, produces nitrogen monoxide gas. Sorry, I did not write, this is 2 water here. I forgot to write 2. Plus 2 water plus 3 iron 3. And this is the balanced redox reaction in acidic conditions. So really what you need to pay attention to is, first of all, assigning oxidation numbers so that you know what's being oxidized and what's being reduced. If you mess this part up, then you're going to mess everything up because the charges will be off. So this was my oxidation reaction. This was easy because there was nothing else to balance. There was just the iron we needed to balance with the charge. This nitrate to nitrogen monoxide, then you have to balance oxygens by adding water, hydrogens by adding hydrogen ions, and then lastly balance the charge by adding electrons. Not forgetting that however many hydrogens you add, that's also affecting the charge. So here we added 4 hydrogens, ions, so 4H plus. So that affects ultimately the number of electrons that we add. Once we get the balanced redox reaction, then we need to make sure that we have equal number of electrons on opposite sides of the arrow so that when we add the balanced half reactions together, the electrons will cancel. Then we will have the balanced redox reactions in acidic conditions.